Hi, welcome to this Corbettmaths video. Today we're going to be looking at the video solutions to the independent events practice questions. If you need any extra help on this probability topic of independent events, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 249, there's a dedicated video tutorial there on independent events. Alternatively, you can scan this QR code. But in this video we're going to focus on the video solutions to the practice questions, so let's get started. Okay, question number one. Question number one says, Gary is playing cricket, and when attempting to catch the ball, the probability that Gary is successful is 3/4. So the probability of him catching the ball is 3/4. And during the game, Gary attempts 2 catches. And the question says, find the probability that Gary is successful with both catches. So we want to find the probability of a catch and another catch. So the probability of a catch and a catch will be found by multiplying the probability of a catch by the probability of a catch, because these are independent events. So the probability of a catch is 3/4, so that's going to be 3/4. So that's the first catch, multiplied by the probability of the second catch, which is 3/4. And then if we do 3/4 times 3/4, that'll be the probability that Gary is successful with both catches. So this is a non-calculator question. So to multiply fractions, we're going to multiply the numerators. 3 times 3 is equal to 9, and then 4 times 4 is equal to 16. So the probability that Gary is successful with both of these catches is 9/16. So the answer is 9/16, 9/16. And that's it. Okay, let's look at our next question, question number 2. Okay, so question number 2 says, Helen has taken part in a quiz on TV, and the probability that she answers a question correctly is 4/5. And the question says that Helen is asked 2 questions. Calculate the probability that she will answer both questions correctly. So we want to find the probability of a correct answer and another correct answer. So to find the probability of a correct answer and another correct answer, because these are independent events, we're going to take the probability of a correct answer, which is 4/5, and multiply that by the next one being correct, which is 4/5. And then when we multiply these together, that'll be the probability that Helen answers both questions correctly. Now again, it's a non-calculator question, so 4 times 4 is 16, and 5 times 5 is 25. So the probability that Helen will answer both questions correctly is 16/25. So that's our answer, 16/25. Okay, let's look at our next question, question number 3. So question number 3 says, a fair 6-sided dice, so it's an ordinary 6-sided dice, is rolled 3 times. And the question is, find the probability that a 6 is obtained all 3 times. So a 6, and then another 6, and another 6. So you want to find the probability of a 6, and another 6. So that's going to be equal to, the probability of the first one being a 6, the first time you roll it would be 1/6, because there's 6 sides on the dice, and the probability of getting a 6 is 1 out of 6. The next one being a 6, well, it's going to be 1 out of 6. And then if you roll it again, the third time will be 1 out of 6. And then if we want to find the probability of getting a 6 and a 6 and a 6, we just need to do a 6 times a 6 times a 6. Well, 1 times 1 times 1 is equal to 1. And 6 times 6 times 6, well, 6 times 6 times 6 is equal to 36. Then we're going to need to multiply that by 6. It's a non-calculator question, so 36 multiplied by 6. 6 times 6 is 36, so put a 6 down and carry a 3. 6 times 3 is 18, plus 3 is 21. So that'll be 216. So the answer would be 1/216th. So 1/216th. So the probability that a 6 is obtained 3 times in a row would be 1/216th. Okay, part B. Part B says, find the probability of getting no 6s. So that's probability of not a 6, not a 6, and not a 6. So the probability of getting not a 6, well, that's any of the numbers apart from 6. That'll be 5, 6, because it's 5 out of 6. Multiplied by, again, not a 6 would be 5/6. And then multiplied by, again, not a 6 would be 5/6, because you've got 1, 2, 3, 4, 5 out of the 6, so it's 5/6. And then if we work this out, let's multiply the numerators together. 5 times 5 times 5, well, 5 cubed is 125, and that's one you should know off by heart. 5 times 5 is 25, times 5 again is 125, and the numerator 6 times 6 times 6 is 216. So the probability of getting no 6s is equal to 125 out of 216, or 125 216ths. So it's much, much, much more likely to get no 6s than it is to get all 3 6s. And that's it. Okay, let's look at our next question, question number 4. So question number 4 says, the probability of rain in Torquay on the 1st of March is 0.7, and the probability of rain in Torquay on the 1st of May is 0.4. We've been asked to work out the probability that it will rain in Torquay on both the 1st of March and the 1st of May. So we want to find the probability of rain and rain. So the probability of rain on the 1st of March is equal to 0.7, so it's going to be 0.7. Multiplied by the probability of rain on the 1st of May would be 0.4. So we just need to do 0.7 multiplied by 0.4. So 0.7 times 0.4, well, 7 times 4 is equal to 28. Well, 0.7 is 10 times smaller than 7. 0.4 is 10 times smaller than 4. So we take our 28 and divide it by 10 and by 10 again. That'll be our answer. So 28 divided by 10 is 2.8, and divided by 10 again would be 0.28. Alternatively, we could look at the question, say we've got 0.7 times 0.4. 0.7 has got one digit after the decimal point. 0.4 has got one digit after the decimal point as well. So in the question, we've got two digits after the decimal points. In the answer, that means we're going to need to have two digits after the decimal point as well. So because we had 28, we'd have to put it after the decimal point. So we'd have those two digits after the decimal point. So the answer would be 0.28. And that's it. Okay, let's look at our next question, question number 5. Okay, so question number 5 says Matthew's playing darts and the probability that he hits a bullseye is 0.3. And Matthew throws 2 darts. And part A says find the probability that Matthew will hit the bullseye with both darts. So we want to find the probability of a hit and a hit. So the probability of him hitting the bullseye with his first dart is 0.3. And the probability that he hits it with his second dart is 0.3. And if we do 0.3 times 0.3, that'll be our answer. So 0.3 times 0.3 would be 0.09. 0.3 is 10 times smaller than 3. 0.3 is 10 times smaller than 3. So we take our 9 and divide it by 10, and by 10 again, we'll get 0.09. Alternatively, we need to have two digits after the decimal point in the answer, so that'll be 0.09. So the answer is 0.09, and that's it. Okay, part B. Part B says find the probability that Matthew does not hit the bullseye with either dart. So it's going to be the probability of a miss and a miss. So if the probability that he hits the bullseye is 0.3, to find the probability that he misses, the probability for a miss, would be equal to 1 subtract 0.3. So we're going to take that away from 1, so that'll be 0.7. So if it's a 0.3 chance of him hitting it, there's a 0.7 chance of him missing it. So the probability of a miss and a miss would be 0.7 multiplied by 0.7. 7 times 7 is equal to 49, so 0.7 times 0.7 would be 0.49. So the answer is 0.49. That's the probability that Matthew does not hit the bullseye with either dart, the probability of him missing and missing again. Okay, let's look at the next question, question number 6. So question number 6 says a biased coin is flipped twice, and the probability that the coin lands on tails is 0.7. So that means the probability that it lands on heads would be equal to 0.3, because if it's a 0.7 chance it lands on tails, then the probability that it lands on heads would be 0.3. And part A says find the probability that the coin lands on heads twice. So we want to find the probability of getting a head and another head. So the probability if it lands on heads is 0.3, so that'll be 0.3 times by 0.3. Well, 0.3 times 0.3 would be 0.09. So the answer would be 0.09. And that's it. Okay, part B. Part B says find the probability that the coin lands on tails exactly once. So we want to find the probability if the coin landed on tails exactly once. So the coin's flipped twice, landing on tails exactly once. That'd be a tail and a head, or a head and a tail. They're the two possible outcomes that it would work, because the coin would land on tails exactly once. A tail and then a head, it lands on tails once, and a head and then a tail, it lands on tails once. So the probability of a tail and a head would be, the probability of getting a tail is 0.7, we're told that in the question, multiplied by the probability of a head would be 0.3, we've worked that out, because remember they have to add together to be 1, so it'd be times 0.3, and 0.7 times 0.3 would be 0.21. The probability of a head and then a tail, well, that's going to be the other way around. The probability of a head would be 0.3. The probability of a tail would be 0.7. And 0.3 times 0.7 is 0.21. So we found the probability of it landing on tails and then heads, and we've also found the probability of it landing on heads and then tails. Now either one of these two options would work, so either this option would work or this option would work, and then if we add them together, that'll give us the probability of the coin landing on tails exactly once. So 0.21 plus 0.21 is 0.42. So the probability that if a coin is flipped twice, this biased coin is flipped twice, that it'll land on tails exactly once would be 0.42. So we find the probability of either of the options that would work, and then we added them together. Okay, let's look at our next question, question number 7. Okay, let's have a look at our next question, question number 7. So question number 7 says a bag contains 6 yellow sweets and 4 blue sweets, and a sweet is taken out at random, it's looked at and then it's replaced, and then another one is taken out. So it's taken out, looked at, and then put back in, and another one's taken out. So because the sweet is replaced and put back in, whenever that second sweet's taken out, there's still going to be 6 yellow and 4 blue. And the question is find the probability if at least one sweet is blue. So we want to find, well, there's a couple of ways we can approach this question. One approach is to consider, well, what are the outcomes that would give us at least one blue sweet? So it would be a blue and then a yellow. We've got at least one blue sweet. A yellow and then a blue, at least one blue sweet. Because there's at least one blue sweet, that would also be a blue and a blue, because it says at least one sweet is blue, well, a blue and a blue would work as well. So those outcomes would all work. They would all be outcomes that would give us at least one blue sweet. So let's find the probability of these and then add them together, and that would be the probability that at least one sweet is blue. So that's one approach, and then I'll talk about another approach afterwards. So let's find the probability of each of these. So the probability of a blue sweet and then a yellow sweet. So the probability that the first sweet will be blue will be 4 out of 10, because there's 10 sweets altogether. There's 4 of them that are blue, so that'll be 4/10. And then, because that sweet's then put back in, there's still these sweets in the bag whenever the second one's taken out, the probability that the second one's going to be yellow will be 6 out of 10, so multiply by 6/10. And then if we multiply these together, that'll be the probability of getting a blue sweet and then a yellow sweet. So 4 times 6 is equal to 24, and 10 times 10 is 100. So the probability of getting a blue sweet and then a yellow sweet would be 24 hundredths. Okay, so that's one outcome that would work. Now we need our next one, our yellow sweet and then a blue sweet, because that's at least one blue sweet. So the probability that the first one will be yellow is 6/10. The probability that the second one is blue would be, because there's then 4 blue sweets still in the bag, so 4/10. And then if we multiply these together, 6 times 4 is 24, and 10 times 10 is 100. So the probability of getting a yellow sweet and then a blue sweet is also 24 hundredths. Okay, and then finally, the probability of getting a blue sweet and then a blue sweet. Well, the probability of a blue sweet is 4/10, multiplied by the probability of a blue sweet, which is 4/10, because remember the sweet's put back in. 4 times 4 is equal to 16, so it'll be 16/100ths. And then we just need to add these together, and if we add them together, that'll give us the probability of getting at least one blue sweet. So let's add together 24 hundredths plus another 24 hundredths plus 16 hundredths. And then if we add those together, that'll be the probability of getting at least one blue sweet. 24 plus 24 is equal to 48. Plus 16 would be equal to 64, so that's 64 hundredths. So the probability of at least one blue sweet would be 64 hundredths. Now we don't necessarily need to cancel that down, the question doesn't tell us to, but I'm going to cancel it down anyway. It'll be 16/25, and that's it, 16/25. So the probability of getting at least one blue sweet would be 16/25. So that's one way we could approach that question, is to find all the possible options that would give us at least one blue sweet, find the probability of them, and then add them up. But there is another way. Because we're taking out 2 sweets from this bag, the bag contains yellow sweets and blue sweets, and we want to find the probability of getting at least one blue. Well, getting the probability of at least one blue, well, if we find the probability of getting 2 yellow sweets, so a yellow and a yellow, and then we take that away from 1, what's left will have to have one blue sweet in there. So let's do 1, take away the probability of a yellow and a yellow. So I'm going to just change colour of ink here to show us there's a different approach here. So we're going to do 1, subtract the probability of a yellow and a yellow. And if we do 1, take away the probability of a yellow and a yellow, all the other outcomes will have at least one blue sweet in it. So let's find the probability of a yellow and a yellow. So a yellow and a yellow. So how many yellow sweets are in the bag? So there are 6 yellow sweets in the bag. So the probability of a yellow and a yellow would be 6/10 multiplied by 6/10. 6 times 6 is 36, and 10 times 10 is 100. So the probability of a yellow sweet and a yellow sweet, 2 yellow sweets, is 36 hundredths. And then if we take that away from 1, that tells the probability of getting at least one blue sweet, because all the other options will have to have at least one blue sweet. So 1, take away 36 hundredths. Remember, 1 is equal to 100 hundredths. So 100 hundredths take away 36 hundredths. Well, 100 take away 36 is 64. So 64 hundredths. And then if we cancel that down, 64 hundredths, if we cancel it down, will be equal to 32 fiftieths. That'll be 16/25. So that finds us the probability as well. So we could either list all the outcomes with at least one blue, and then find all of those probabilities and add them together, and then we got our answer of 16/25. Or we could do 1, take away the probability of 2 yellows, because then that would tell us the probability of having an outcome which has at least one blue in it. And that's it. Okay, let's look at our next question, question number 8. So question number 8, we've got this spinner, and it's got sections of equal size, 1, 2, and 3. And the spinner spun twice, and the score is found by adding the numbers together. And part A says find the probability of getting a score of 6. So if it's spun twice and we want to get a score of 6 and the numbers are added together, the only way we can do that is getting a 3 and then another 3. So we want to find the probability of getting a 3 and then another 3. Now, because these sections are of equal size, that means it's a fair spinner, so the probability of getting a 3 would be 1/3, so 1/3. Multiplied by, the next one would be 1/3, because to land on a 3, the chance of landing on a 3 is a third, so the probability of getting a 3 and then another 3 would be a third multiplied by a third. 1 times 1 is equal to 1, and 3 times 3 is equal to 9. So the probability of getting a score of 6 is 1/9, so 1/9. Okay, part B. Part B says find the probability of getting a score of 5. So with this spinner, we're going to spin it twice and add the numbers together. Now to get a 5, we could get either a 3 and then a 2, or a 2 and then a 3. So let's find the probability of getting those. So the probability of a 2 and then a 3, well, the probability of getting a 2 would be 1/3. The probability of getting a 3 would be 1/3. We'd multiply those together, so that'll be 1 times 1 is 1, and 3 times 3 is 9. The probability of getting a 3 and then a 2, well, the probability of getting a 3 is 1/3. The probability of getting a 2 is 1/3. If we times them together, again, that'll be 1/9. So the probability of getting a 5, well, we're going to add these two probabilities together. A 9th plus a 9th is equal to 2/9. So the probability of getting a score of 5 would be 2/9. Okay, and then part C. Part C says the probability of getting a score of 4. So looking at the spinner, well, to get a 4, we could get a 2 and then a 2, or a 1 and then a 3, or a 3 and then a 1. So there's 3 different ways to do that. So we're going to get the probability of getting a 2 and then a 2, the probability of getting a 1 and then a 3, and the probability of getting a 3 and then a 1. And then we'll add those probabilities together. A 2 and then a 2, that'll be a third multiplied by a third, which is 1/9. The probability of getting a 1 and then a 3, that'll be 1/3 multiplied by 1/3, because the probability for each of those is a third. Multiply them together would be 1/9. And the probability of getting a 3 and then a 1, so the probability of getting a 3 would be 1/3, multiplied by the probability of a 1, which is 1/3, and when we times them together, we get 1/9. So the probability of getting a 4 would be either this option, or this option, or this option. So we'll add them together, so that'll be 3/9. So you could write 3/9 as your answer. I'm going to cancel it down to be 1/3. The question doesn't tell us that we have to cancel it down, so you could write 3/9, and that's fine, but I'm just going to write down 1/3 because I like to cancel it down if I can. Okay, and then finally part D. Part D says find the probability of getting a score of 7. So if we go back up, we're going to spin the spinner twice. Now the greatest score we can get, the highest score we can get is 6 because of 3 and then another 3. So we can't actually get 7, it's impossible. So that means the probability of getting a score of 7 would be 0, and that's it. Okay, let's have a look at our next question, question number 9. So question number 9, a bag contains 10 counters, 5 are red, 3 are purple, and 2 are white. Sharon's going to choose a counter at random. She's going to record the colour and replace it, so she's going to put it back in. So then after she puts it back in, we'll still have 5 red, 3 purple, and 2 white. Sharon's then going to choose another counter at random and record the colour. And the question is, what's the probability that both counters are the same colour? So both the same colour, well, that'll be either a red and then a red, a purple and then a purple, or a white and then a white. So let's find those probabilities. So let's find the probability of a red and a red. Let's find the probability of a purple and then a purple. And let's find the probability of a white and then a white. So the probability of a red and a red, well, the probability of the first one being red would be 5 out of 10, 5/10. The probability of the next one being red would also be 5/10. And then if we times them together, 5 times 5 is 25, and 10 times 10 is 100. So the probability of a red and a red would be 25/100ths. Or that could be cancelled down to a quarter, but I tend not to cancel down until the very end, because when we multiply these together, we'll probably find that we get 100 as the denominator for all of them, and it's easier to add them together. Okay, next, the probability of a purple and then a purple. So the probability of the first one being a purple is 3/10. The probability of the next one being a purple would also be 3/10, because remember the counters put back in, so there's still going to be 3 purple counters out of the 10. 3 times 3 is 9, and then 10 times 10 is 100, so that's 9/100ths. And then finally, the probability of a white and then a white, well, the probability of a white one is going to be 2/10, and then the probability of the next one being white would be 2/10. And then if we times them together, 2 times 2 is 4, and 10 times 10 is 100. So the probability of getting a red and a red would be 25/100ths. The probability of getting 2 purples would be 9/100ths, and the probability of 2 whites would be 4/100ths. And that's fantastic, because now we've been asked to find the probability that the counters are the same colour. We've got all the probabilities for all the outcomes where they're the same colour. We just need to add them together now. So 25 plus 9 is 34, plus another 4 would be 38. So if we add them together, we're going to get 38/100ths. So that's the probability that the two counters are the same colour. And then I like to cancel it down. Now you could just write the answer as 38/100ths, and that's fine. But I'm going to half both of those to be 19/50ths. So the probability that the counters are the same colour are 19/50ths, and that's it. If the question asks us what's the probability that the counters are not the same colour, I probably would then use the same approach, find the probability of them being the same colours to be 19/50ths, and then I'll take that away from 1, which is 31/50ths. So rather than doing a red and a purple, a red and a white, a purple and a red, a purple and a white and a red and a white and a purple, I would just find the probability of getting 2 reds, 2 purples and 2 whites, add them together and take them away from 1, and every other option they would be different colour. But here we'll find the probability of the two counters being the same colour as 19/50ths, and that's it. Okay, let's look at our next question, question number 10. So question number 10, we've got a bag with 5 discs. We've got a red disc, a green disc, a white disc, and a pink disc. So there's 2 red, 1 green, 1 white, and 1 pink. And the game's played where a disc is removed, the colour is noted, and then it's replaced, so it's put back in, and then another disc is taken out. And then the question says, calculate the probability that the discs removed are different colours. So if we think back to our last question, we could do red and green, red and white, red and pink, green and red, green and white, green and pink, white and red, white and green, white and pink. I'm losing track here. Pink and red, pink and green, pink and white. Or an easier way would be to find the probability of them being the same colour. So a red and a red, a green and a green, a white and a white, and a pink and a pink. And then if we take that away from 1, then that'll be the probability of them being a different colour. So let's do that. So we're going to do 1 subtract the probability of them being the same colour, and that'll be the probability that they're different. Okay, so the same colour, so it's going to be a probability of a red and a red, the probability of a green and a green, the probability of a pink and a pink, and the probability of a white and a white. Okay, so probability of a red and a red. There's 2 reds out of the 5 counters, so that's going to be 2/5 multiplied by 2/5, which would be 2 times 2 is 4, so that's going to be 4, and 5 times 5 is 25. So the probability of getting 2 reds would be 4/25. I remember they're put back in, that's why the probabilities are staying the same. Okay, the probability of getting a green and a green, well, that's going to be 1/5, because there's 1 green out of the 5, multiplied by 1/5. So that'll be 1 times 1 is 1, and 5 times 5 is 25, so that's 1/25. The pink and a pink, well, that's going to be the same as a green and a green, because 1/5 times 1/5, which is 1/25. And a white and a white, again, that's going to be 1/5 times 1/5, which would be 1/25. So we now know the probability of getting a red and a red, a green and a green, a pink and a pink, and a white and a white. If we add them together, the probability of them being the same colour, so getting 2 of them the same colour then would be 4/25 plus 1/25, that's 5/25, 6/25, 7/25, so that's 7/25. So that's the probability that they're the same colour. And then if we do 1 take away the probability that they're the same colour, then we'll get the probability that they'll be different colours. So then 1 take away 7/25, so 1 is 25/25, and 25 take away 7 is 18, so the answer would be 18/25. So the answer is 18/25. And that's it, and that's how I'd approach that question, rather than doing a red and a pink, red and a white, red and a green, and so on, and doing all those. And you know, there might be the chance that I'd miss one. I think this is much easier. Find the probability that they're the same colour, and then do 1 subtract that. Okay, let's look at our next question, question number 11. Okay, so question number 11. Okay, so let's have a look at our next question, question number 11. So question number 11 says a triangular spinner has 3 sections of equal size. We've got 1 section that's red, 1 section that's white, and 1 section that is yellow. And the spinner is spun 3 times. So the spinner is going to be spun 3 times. And that means because each of the sections are equal size and it's a fair spinner, that means the probability that it lands on red is going to be 1/3. The probability that it lands on yellow will be 1/3, and the probability that it lands on white will be 1/3 as well. And the spinner is spun 3 times. And part A says find the probability that the spinner will land on red at least once. So at least once. Now if we were to write down all the outcomes that would have the spinner landed on red at least once, there'd be loads of them. For instance, you could have red, white, white, red, white, yellow. Because there's at least one, so it could be red, 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 yellow, red. There'd be lots of them. So the easiest way to find the probability that it lands on red at least once, so at least 1 red, would be to actually do 1 subtract the probability of no reds. Because if we can find the probability of there being no reds, the spinner not landing on red at all, then all the other outcomes will have at least 1 red. And then that would be the probability of at least 1 red. So we need to do 1 subtract the probability of no reds. And that's a much easier way of doing it rather than doing red, white, red, red, white, white, red, yellow, red, and so on. There'll be lots of different outcomes there. So let's work this out. So the probability of no reds, would be, well, the first one of not landing on red, well, we've got, that means that the spinner can either land in yellow or white. So that means it'd be 2/3, because there's a 1/3 chance of it landing on red and a 2/3 chance of it not landing on red. So the probability of the spinner, whenever we spin it once, of it landing on not red will be 2/3. So 2/3. And then we're going to spin the spinner again, and then the probability of it not landing on red again will be 2/3. And then we spin it 3 times, so it's spun again, so then the probability of it not landing on red again will be 2/3. So if we want to find the probability of no reds, we're going to do 2/3 multiplied by 2/3 multiplied by 2/3. So let's do that. 2 times 2 is 4 times 2 is 8. and 3 times 3 times 3 is 27. So the probability of there being no reds would be 8 27s. So if we want to find the probability of at least one red, we're going to do 1 subtract the probability of no red. So we're going to do 1 subtract 8 27s, because that means that all the other options will have at least one red. So 1, that's 27 27s. Take away 8 27s would be 19 27s, so 19 27s. So the probability that the spinner lands in red at least once will be 19 27s. And that's it. Okay, let's have a look at our next part. Part B says find the probability that the spinner lands on white exactly twice. So we want to find the probability of this spinner landing on white exactly twice. So that could be white, white, red, white, white, yellow, white, red, white, white, yellow, white, and finally red, white, white, and yellow, white, white. I think I've done them all right there. So that's one way you could do it and find the probability of all 6 of those possible outcomes. Alternatively, what we could do is we could say white, white, not white, and we could have white, not white, white, and not white, white, white. So let's do that. So let's do the probability. So the way I'm going to do it is I'm going to do white, white, not white, and then I'm going to do white, not white, white, and then finally not white, 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 because there'll be all the possible outcomes that would have at least one white. And the reason I've done that is rather than having to do white, white, red, and white, white, yellow, this is just a bit quicker and easier. So white, the probability of landing on white was 1/3. The probability of it next landing on white would be another 1/3. And then it landing on not white would be 2/3, because there's 2 of them that are not white. And then if we multiply these together, 1 times 1 is 1, times 2 is 2, and 3 times 3 times 3 is 27, so that's 2 27s. Next, white, not white, white, so white will be 1/3, not white would be 2/3, and white again will be 1/3. And if we times them together, 1 times 2 times 1 is equal to 2, and then the denominator would be 27. And then finally, not white, 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 so not white would be 2/3, white would be 1/3, and white would be 1/3. And then if we times them together, again, 2 times 1 times 1 is 2, and 3 times 3 times 3 is 27. So we now know the probability of getting white, white, not white, white, not white, white, and not white, white, white. And that means then if we want to find the probability that the spinner lands on white exactly twice, we just need to add together these probabilities. So if we do 2 27s plus 2 27s plus 2 27s, that would be equal to 6 27s, so 6 27s. And you could leave your answer like that if you wanted to. Now both of these numbers are divisible by 3, so I'm going to divide them both by 3, and that gives me an answer of 2/9. So that means the answer is 2/9. So the probability that the spinner lands on white exactly twice would be 2/9. And that's it. Okay, let's look at the next question, question number 12. Okay, let's have a look at the next question, question number 12. So question number 12 is a calculator question, so that's great. I've got my calculator here. And it says that Harry's going to get the train to work in the morning, and he works Monday to Friday, and the probability that the train is late is 0.2. And that means the probability that it's going to be on time would be, the rest would be 0.8. So the probability of on time would be 0.8. And then we're asked to find the probability that the train is late exactly once over the 5 days from Monday to Friday. Okay, so he's getting the train 5 times because he's getting the train to work in the morning. So he's going to get the train on Monday, Tuesday, Wednesday, Thursday, and Friday. The probability that it's late is 0.2. The probability that it's on time is 0.8. And we've been asked to find the probability that the train is late exactly once. In terms of our possible outcomes, that could be on time, on time, on time, on time, late. So just late on Friday. It could be on time, on time, on time, late, on time. It could be on time, late, on time, on time. It could be on time, late, on time, on time, on time. And it could be late, on time, on time, on time, on time. So we've got these 5 possible outcomes where the train would be late exactly once. And now let's find the probabilities of each of them. So the probability of on time, on time, on time, on time, late would be on time is 0.8. The probability of being on time is 0.8. So that'd be 0.8. The probability of the train being on time again would be another 0.8, and then another 0.8, and another 0.8. We could actually write here 0.8 to the power of 4, but I probably would just jot it out like this to begin with, and then multiply by, and then probably if it being on time would be 0.2. And then if we work this out in our calculator, if we do 0.8 to the power of 4 times 0.2, or 0.8 times 0.8 times 0.8, and so on, 4 times, and times by 0.2, that gives us an answer of 0.08192. So that's the probability of the train being late on Friday, but on time all the other 4 days. Now, if we want to find the probability of on time, late, on time, that's going to be 0.8 times 0.8 times 0.8 times 0.2 times 0.8. Now, if you notice here, we've got the same numbers, but just in a different order. So whenever we multiply them together, we're still going to get 0.08192. And again here, it's going to be 0.8 times 0.8 times 0.2 times 0.8 times 0.8. Again, it's the same number, so again, the answer would be 0.08192, 0.08192, and 0.08192. And that means that if we want to find the probability that trains late exactly once over the course of a week, we just need to add together these probabilities, or do 0.08192 multiplied by 5. And when we do that, we get an answer of 0.4096. So the probability that the train's going to be late exactly once would be 0.4096, and that's it. Okay, so question number 13, it says that James, Fred and Kevin each take a penalty, and the probability that James scores is 4/5, the probability that Fred scores is 2/3, and the probability that Kevin scores is 3/4. And we've been asked to find the probability that all three score. So that'll be the probability of James scoring, which is 4/5, multiplied by the probability that Fred scores, which is 2/3, multiplied by the probability that Kevin scores, which is 3/4. And then if we work that out, and it's a calculator question, that'll tell us the probability of all three scoring. So let's work that out. And that's equal to 2/5, or 0.4. So 2/5. So the answer is 2/5. Okay, and then part B. Part B says find the probability of at least 2 boys scoring. So at least 2 boys. So that could be 2 of them or 3 of them, because it says at least 2. So in terms of those outcomes, that would work. So at least 2 scoring. That could be all 3 scoring, James, Fred and Kevin. Or it could be James scoring, Fred scoring and Kevin missing. Or James scoring, Fred missing and Kevin scoring. Or it could be James missing, Fred scoring and Kevin scoring. So let's work those out. So that would be the probability of all 3, which we've actually worked out already, which is equal to 2/5. And then we've got the probability of score, score, miss, or score, miss, score, or miss, score, score. So let's work out those probabilities and see what we get. So score, score, miss. So the probability of James scoring is 4/5. The probability of Fred scoring was 2/3, so times 2/3. And then the probability of a miss. So here, in terms of Kevin, the probability that Kevin scores is 3/4. So it means the probability that he misses, the probability that Kevin misses would be equal to 1/4, because 3/4 taken away from 1 take away 3/4 would be 1/4. The probability of Fred missing would be equal to, if the probability that he scores is 2/3, the probability that he misses would be 1/3, because they have to add together to be 1. And finally, the probability of James missing would be equal to 1/5, because obviously 1 take away 4/5 would be 1/5. So when we go to find the probability of score, score, miss, the probability of Kevin missing was 1/4, so times 1/4. So if we do 4/5 times 2/3 times 1/4, that'll tell us the probability of score, score, miss. So let's do that. And that's equal to 2/15. And this is a calculator question, so I'll just type that in on my calculator. Okay, score, miss, score. So score was 4/5. And then miss, well, the probability of Fred missing was 1/3, because the probability that he scores is 2/3, so the probability that he misses is 1/3, times the probability that Kevin scores is 3/4. And it's always useful to just go back up and make sure you've got the right numbers there. So score, miss, score, yeah. Okay, and then if we just times them together, that'll give us the answer there. So that would be equal to 1/5. So 1/5, whenever we multiply those together in our calculator, we'll get 1/5. And finally, miss, score, score. So miss, score, score would be miss 1/5 times score 2/3 times 3/4. So let's write that down. And whenever we work this out in our calculator, we get an answer of 1/10. So we've now found the probability of all the outcomes that have at least 2 boys scoring. So we've got the probability of score, score, miss, miss, score, 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 and all 3 scoring. So if we add them together, so 2/5 plus 2/15 plus 1/5 plus 1/10, we'll find the probability of at least 2 boys scoring. So let's do that. And the answer is 5/6. So 5/6, so the probability of at least 2 boys scoring would be 5/6, and that's it. Okay, so let's have a look at our next question, question number 14. So question number 14 says there's 7 tiles in a bag and each with a letter written on it. And we've got the letters P-O-L-Y-G-O-N, so polygon, and a tile selected at random and it's replaced. So after it's taken out, it's looked at and then put back, and then another tile selected. So the probabilities are going to stay the same. And then the question says find the probability that both tiles have a different letter on it. So in other words, like a P and an O, a P and an L, P and a Y, and so on. Now if we were to consider that, there'd be quite a lot of different outcomes: PO, PL, PY, PG, PN, OP, OL, OY, and so on. And there's going to be lots of different outcomes. So the easiest way to do this question would be to find the probability that the two letters are the same. And then if we can find the probability that the two letters are the same, we can then do 1 subtract the probability that they're the same, and then that'll tell us the probability that they'll be different. So the probability of different, so the probability that they're different, would be equal to 1 subtract the probability that they're the same. So let's find the probability that the two letters are the same. That would be the probability of a P and another P, the probability of an O and another O, the probability of an L and another L, the probability of a Y and another Y, the probability of a G and another G, and the probability, well, we've done O and O already, so the probability of an N and another N. And then if we can find all those probabilities, then we can add them together. That'll tell us the probability of the two tiles having the same letters on them, and then we can do 1 subtract that, because then all the other options would be the probability that they're different to each other. So the probability for P and another P. So let's just see kind of see how many tiles there are. There's 1, 2, 3, 4, 5, 6, 7. So it's going to be the probability for P will be 1/7 multiplied by 1/7, and that'll be equal to 1/49. Okay, the probability of an O and another O. So the probability of an O is equal to 2/7, because there's 2 of them, 2/7. And then the next one being an O would be 2/7 as well. And 2/7 times 2/7, well, 2 times 2 is 4, and 7 times 7 is 49. So that's 4/49. The probability of an L and another L would be 1/7 times 1/7, so that'll be 1/49 again. The probability of a Y and another Y, that'll be 1/49 again, because it's a 7th times a 7th, that'll be 1/49, and that'll be 1/49 as well. So we've worked out all the probabilities. So we've worked out the probability of a P and another P, an O and another O, an L and another L, a Y and a Y, a G and a G, and an N and an N. Now if we add those together, that'll tell us the probability that they're the same. So the probability that they're the same, those two tiles, would be 1, 5, 6, 7, 8, 9, 9/49. So the probability that the two tiles have got the same letter on it are 9/49. So if we want to find the probability that both tiles have different letters on it, we're going to do 1 subtract that probability. So 1 take away 9/49. Now 1 is 49/49. Take away 9/49 would be 40/49. And that's it. So the probability that the two tiles have got different letters on them are 40/49. And that's it. Okay, let's look at our next question. Okay, so question number 15. Question number 15 says that a fair spinner has got 4 sections, and where they're labelled 1, 2, 2, and 3. And the spinner is spun 3 times, so it's going to be spun 3 times, and the numbers are added together to give a score. And we've been asked to find the probability that the score at the end is even. So we want to find, if we're adding these 3 numbers together, because it's spun 3 times, so it's going to be 3 numbers that are added together, what's the probability that it's going to be even in terms of the final outcome? So let's consider the options that would give us an even answer. So we can have an even plus an even plus an even. That would give us an even. We could have an even plus, we can't do an even plus an odd, because an even plus an even is an even plus an odd would give us an odd, so that one wouldn't work. An even plus an odd plus an even would also give us an odd, because an even plus an odd is odd, plus an even is going to be odd, so that wouldn't work. And also an odd plus an even would also give us an odd. So if there's only one odd, then the answer will be odd, because the 2 evens will add together to be an even, and then that 1 over odd will make the final answer odd. So you can't have any options with just one odd number. So we've got even plus even plus even, that would work. Now let's consider 2 odd numbers. So even plus odd plus odd. So an odd plus an odd is an even, plus an even would be even, so that would work. So 2 odds would work. So that means we could also have an odd plus an even plus an odd, or we could have an odd plus an odd plus an even. All those would work, so they would all give us evens. So that would work, that would work, and that would work. And then finally, an odd plus an odd plus an odd, odd plus an odd plus an odd, that would give us an odd, so that's not going to work. So we want to find the probability of an even number, an even number, and an even number, an odd number, and an odd number, an odd number, an even number, and an odd number, and an odd number, an odd number, and an even number, and all those outcomes would work. So let's do that. So the probability of an even, and an even. So an even. Well, there's 1, 2, 3, 4 sections, and 2 of them are even. So the probability of an even would be 2/4 or 1/2. So the probability of an, let's actually write them down here, the probability of an even would be equal to 1/2, and the probability of an odd is equal to 1/2, because it's 2/4, which is 1/2. So we've got the probability of each of them. So the probability of an even, an even, and an even would be 1/2 times 1/2 times 1/2. And the probability of an even, an odd, and an odd, an even, an odd, and an odd, that would be 1/2 times 1/2 times 1/2. So, and then that would be our answer. So let's actually work these out. 1/2 times 1/2 times 1/2 is an eighth. 1/2 times 1/2 times 1/2 is also an eighth, because 1 times 1 times 1 is 1, and 2 times 2 times 2 is 8. Okay, so we found those ones, and then we need to find the probability of an odd, an even, and an odd, and the probability of an odd, and an even. So that would be 1/2 times 1/2 times 1/2 as well, because probably of an odd and an even, they're all half, so it's going to be equal to 1/8, and the probability of an odd and an even would be 1/2 times 1/2 times 1/2, which would also be equal to 1/8. So that means that the probability of this outcome, this outcome, and this outcome, and this outcome, so that means the probability of all these 4 outcomes is an eighth. So if we add them all together, so an eighth plus an eighth plus an eighth plus an eighth, that tells us the probability of getting an even score at the end. So adding those together would be 4 eighths, and then we could cancel that out, if we wanted to be 1/2. So the probability of getting an even score is 1/2, and that's it. Okay, so let's have a look at our next question, question number 16. So question number 16 says 3 biased dice are going to be rolled, and the probability that all 3 dice show a 6 is 0.343. And we've been asked to find the probability that none of the dice show a 6. Okay, so this question is a bit different than the ones before, because in the questions before we were told the probability of perhaps it landing on a 6, and then we had to find the probability that all 3 dice would land on 6s and so on. So what I'm going to do this time is I'm going to let the probability that the dice lands on a 6, so the probability that it lands on a 6, to be equal to y, so a particular number. So it's going to be 0 point something. Okay, so there's going to be a probability that it lands on a 6, and we're going to let that be equal to y. Now, if all 3 dice land on a 6, the probability of that's going to be equal to 0.343. So the probability that it lands on a 6, and another 6 would be equal to 0.343. And we would work that out by taking the probability that it lands on a 6, which is y, so y, and we would times that by y, and we would times that by y, and that would be equal to 0.343. So whatever the probability of this biased dice landing on a 6 is, we would times it by itself and by itself again, and that would give us 0.343. So that means that if we take this answer and we take the cube root of it, we can find out what y is, because here we've got y times y times y, which is y cubed, and that's equal to 0.343. So if we work out the cube root of 0.343, that'll tell us what y is. So on our calculator, if we do the cube root of 0.343, we get that's equal to 0.7. So that means that y is equal to 0.7. That means the probability that it lands on a 6 is 0.7. So y is equal to 0.7. So this dice is definitely biased. There's a 70% chance it's going to land on a 6. And we've actually been asked to find the probability that none of the dice show a 6. So that's a probability of not a 6, not a 6, and not a 6. So not a 6, the probability of not a 6 would be equal to 0.3. So it'll be 0.3 times 0.3 times 0.3. And if we work that out, that'll tell us the probability of none of the dice showing a 6. So 0.3 times 0.3 times 0.3 is 0.027. So the probability that none of the dice show a 6 is equal to 0.027. And that's it. So in this question, we worked out the cube root of 0.343, and that was equal to 0.7. We then took that away from 1 to find the probability of it not landing on 6, which would be 0.3. And then we done 0.3 times 0.3 times 0.3, and that's equal to 0.027. And that's it. So that's the probability that none of the dice show a 6. Okay, let's look at our next question, question number 17. Okay, so question number 17 says, Aidan designs a game, and as part of the game, each spinner spins a biased spinner with 5 sections. So this spinner has got 5 sections, and it's biased. And the player scores the number of points shown in the section the spinner lands on. So if it lands on a 0, you get 0 points. So here we've got the number of points, 0, 2, 4, 6, and 8. And in the table, we've got the probability. So the probability for 0 is 0.15. So the probability if the spinner lands on a 0 is 0.15, and so on. And here we actually can see the probability that it lands on a 6 is x, so we don't actually know all the probabilities. And the question says find the probability that the spinner will land on 6 points. So all these probabilities will add together to be equal to 1. So that means that if we add these probabilities, this one, this one, this one, and this one, and take it away from 1, we can find the probability of the spinner landing on a 6. So let's do that. And it's a calculator question, so we just need to do 0.15 plus 0.12 plus 0.09 plus 0.37 and see what we get. And that's equal to 0.73. And then if we do 1 take away 0.73, that's equal to 0.27. So the probability of the spinner land on a 6 would be 0.27, so 0.27. And then we're told during the game a player spins the spinner twice, and if she scores a total of 14 points or more, she wins the game. Find the probability that she wins the game. Okay, so 14 points or more, she wins the game. So let's find the outcomes which would give us 14 points or more. An 8 and then another 8, that would be equal to 16 points. That would work, an 8 and an 8. 14 points, so that's going to be an 8 and a 6. They would add together to be 14 points because 14 points or more, that would work. And also 6 and an 8, so 6 and an 8. That would also give us 14 points. So that would also mean that the player wins. And no other options would work because the next highest would be a 6 and a 6, which would be equal to 12, so that's not big enough. So we want to find the probability of an 8 and an 8, an 8 and a 6, and a 6 and an 8, and then add them all together. So let's write that down. The probability of an 8 and an 8, the probability of an 8 and a 6, and the probability of a 6 and an 8. Okay, so the probability of an 8 and an 8. So the probability of an 8 is 0.37. So it's going to be 0.37 multiplied by 0.37, and we'll see what we get. An 8 and a 6, so that'll be 0.37 multiplied by 0.27. And we'll multiply those and see what we get. And finally, a 6 and an 8, that'll be 0.27 multiplied by 0.37. So let's work these out and see what we get. So 0.37 multiplied by 0.37 is equal to 0.1369. 0.37 times 0.27 will be equal to 0.0999. 0.27 times 0.37 would be equal to 0.0999 as well. So we've got the three probabilities. Now we just need to add them together and see what we get. So if we add them together, that's equal to 0.3367. So that means the probability that the player wins the game is 0.3367. And that's it. Okay, let's look at our next question. Okay, let's have a look at our next question, question number 18. So question number 18 says a bag contains yellow and green beads in the ratio 1 to 3. So it means for every 1 yellow bead, there's 3 green beads. And Tamara takes a bead at random from the bag. And she notes the colour and then replaces the bead in the bag. So that means that once she puts the bead back in the bag, the ratio will still be 1 to 3. And Tamara does this 3 times. And the question says find the probability that all 3 beads are not the same colour. Okay, so let's have a look at this question. We're told the ratio of yellow beads to green beads is 1 to 3. So that means that for every 1 yellow bead, there's 3 green beads. So there could be 1 yellow and 3 green. So that there could actually be 1 yellow and 3 green beads in the bag. We're not actually told how many beads there are in total. There could be 2 yellow and 6 green. There could be 3 yellow and 9 green, and so on. Now, no matter how you do it, if you were to find the probability of a yellow, for instance, if there was 1 yellow and 3 green, the probability of a yellow, if there was yellow, green, 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 the probability of a yellow would be 1 out of 4, and that would be 1/4. Or if there was actually 2 yellows and 6 green, well then it would be 2 out of 8, which would cancel down to be 1/4, and so on. So that means the probability for yellow would always be 1/4, no matter how many yellow and green beads there are. If they're in the ratio 1 to 3, the probability for yellow is going to be 1 out of 4, 1/4. The probability of a green bead would then be 3/4, because it could be 3 out of 4, so 3/4, or 6 out of 8, which would cancel down to 3/4, and so on, or 3 out of 4 parts, so that would be 3/4. Okay, so we find the probability of a yellow and the probability of a green. Now we want to find the probability that the 3 beads are not the same colour. Now rather than doing yellow, yellow, green, green, yellow, 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 green, yellow, and so on, what I'm going to do is I'm going to do 1 subtract the probability that they're the same. And if we do 1, take away the probability that they're the same as each other, that'll tell us the probability that all 3 beads are different colours. So let's find the probability of a yellow, and a yellow. And then that'll be the probability that they're the same as each other. And then if we do the probability of a green and a green and a green, then that's the probability that these 3 beads are the same colour as each other. And then if we add them together, that'll be the probability that the beads are the same colour. And then if we do 1 take away that answer, that'll tell us the probability that they're different to each other. So the probability of a yellow, and a yellow. So the probability of the first one being yellow is 1/4. The probability of the next one, because the beads put back in, of the next one being yellow, will be 1/4 as well. And then the next one being yellow will be 1/4. And if we times them together, 1 times 1 times 1 is 1. And 4 times 4 times 4 is equal to 64. So it'll be 1/64. The probability of a green and a green and a green, that's going to be 3/4 times 3/4 times 3/4. So 3 times 3 times 3 is 27, and 4 times 4 times 4 is 64. So that'll be 27/64. And then if we add them together, that'll be the probability that the beads are the same colour. The 3 beads are the same colour as each other. So that'll be 28/64. Now, if we want to find the probability that the beads are not the same colour, we're going to do 1 take away the probability that they're the same colour. So we're going to do 1 take away 28/64. And that's 64/64, because that's 1, take away 28/64, and that would be equal to 36/64. And then if we cancel that down, that would be equal to, we can divide both of these by 4, the numerator and denominator by 4, that'll be equal to 9/16. So the probability that the 3 beads are not the same colour as each other are 9/16. And that's it. And in that question, what I done was I found the probabilities of the yellow and the green to begin with by considering the ratio. And then because the beads put back in, that means that the probabilities will always be 1/4 and 3/4. And then we find the probability that the 3 beads are all yellow and the probability that the 3 beads are all green. We added them together to find the probability that the 3 beads are the same colour as each other. And then we took that away from 1, and that's equal to 9/16. Okay, let's look at our next question, question number 19. Okay, let's have a look at our next question, question number 19. So question number 19 says, shown below is a spinner. So we've got the spinner, and it's got yellow, it's got pink, and it's got blue. And obviously we've got here, this is a right angle, so this is a 90-degree angle here. And Daisy's going to spin this spinner twice. And the probability that the spinner lands on blue, this section here, twice is 9/400ths. So 9 out of 400. And we've been asked to work out the size of the angle of the blue sector. So we want to find the size of this angle here. Let's just call it X. So we want to find the size of that angle. Okay, so we're told that the probability that the spinner lands on blue twice is 9/400ths. So that means the probability of a blue and another blue is equal to 9/400ths. So that means that the probability of a blue times the probability of a blue will be equal to 9/400ths. So that means if we want to find the probability of a blue, we're just going to square root this. So on our calculator, we'll do the square root of 9/400, and that's equal to 3/20ths. So that means the probability of a blue would be 3/20ths, 3/20ths, and we can check that. 3/20ths times 3/20ths would be 9/400ths. So it means the probability of a blue is 3/20ths. Okay, now we want to find the size of this angle. Now the probability of getting a blue is equal to 3/20ths. Now let's just consider the pink section for a minute. This angle is 90 degrees, and we know the probability of getting a pink is 1/4 because it's 1/4 of the whole circle. And if we do 90 over 360, that's equal to 1/4 if you cancel it down. And if you do 1/4 of 360, that's equal to 90. So if we take 3/20ths of 360, that'll tell us the size of this angle, because the 3/20ths would be the fraction of the whole circle. So we just need to do 3/20ths of 360, and that'll be the size of this angle. So 360 divided by 20 is equal to 18, times by 3 is equal to 54. So that'd be 54. So that means that this angle is 54 degrees. So that means that this angle here is 54 degrees. So the angle of the blue sector is 54 degrees. Okay, next, part B. Part B says find the probability of the spinner landing on yellow twice. So we want to find the probability that it lands on yellow twice. Okay, well that's fantastic because we know the size of this angle and we've got the size of this angle, so we can find the size of this angle here. So if we do 360, the whole circle, the degrees of the whole circle, take away 90 degrees and take away 54 degrees, so take away 90 and take away 54. Let's see what size that angle is. So 360, take away 90, take away 54 is equal to 216 degrees, 216 degrees. So that's 216 degrees. And if we wanted to then find the probability of this spinner landing on yellow, it's going to be 216 out of 360. So let's write that down. The probability of yellow will be equal to 216 over 360. And if we cancel that down, that's equal to 0.6 or 3/5. So that's equal to 3/5. So that means the probability that the spinner lands on yellow is 3/5. So if we want to find the probability that it lands on yellow twice, that's a yellow and a yellow, we're going to do 3/5 multiplied by 3/5. 3 times 3 is equal to 9, and 5 times 5 is equal to 25. So the probability that this spinner lands in yellow twice would be equal to 9/25. So 9/25, and that's it. Okay, let's look at our next question. Okay, so question number 20. Question number 20 says that Tom and Ben sit their driving tests and the two events are independent. So perhaps they're not using the same driving instructor and there's not a quota in terms of how many pass or fail and so on. And the probability that Tom passes is 0.4 and the probability that only one man passes is 0.56. And we've been asked to find the probability that they both fail. Okay, so let's have a look and see what information we're told. We're told the probability that Tom passes is 0.4. So the probability of Tom failing would be equal then to, Tom fails, would be equal to 0.6. Because the probability that he passes or fails must add together to be 1. So if we do 1 take away 0.4, that's 0.6. Okay, and then we want to find the probability that they both fail. So let's consider Ben for the minute. So let's let the probability of Ben passing be equal to x. So we're just going to let the probability that Ben passes be equal to x. That could be 0.7 or 0.2 or 0.9 and so on. And that means the probability that Ben fails, so probability that Ben fails, would be equal to 1 take away whatever x is. Like in terms of Tom, we done 1 take away 0.4. So here we do 1 take away x. So what we've done there is we've got what the probability that Tom passes is 0.4. We've got the probability that Tom fails is 0.6. We've let the probability of Ben passing be x, and that means the probability that Ben fails is 1 minus x. Now we're told the probability that only one man passes is 0.56. So because only one man passes, that could mean that Tom passes, so Tom passes, and Ben fails, so Ben fails. Or it could be that Tom fails, so Tom fails, and Ben passes, and Ben passes. Excuse my writing there for the hand, and Ben passes. Okay, so yeah. Okay, so in terms of probability of Tom passing and Ben failing, so Tom passing is 0.4, so it's going to be 0.4 multiplied by Ben failing. Well, that's going to be 1 minus x. Now I'm going to put that in a bracket. I'm just going to write 1 minus x like so. So Tom passing is 0.4 multiplied by Ben failing, which is 1 minus x. And that's what we've written there. And then because it's either this option or this option, because it's either that option or that option, we're going to add them together because it's one man passing. So it's either this option or this option. So if we were working at this question, we would work at that probability. We'd work at that probability and then we'd add them together. So I'm going to put plus. And then Tom failing. So Tom failing is 0.6. multiplied by Ben passing. So multiplied by Ben passing, which is x. So we would do 0.6 multiplied by x to find the probability of Tom failing and Ben passing. And we know that when we find the probability of only one man passing, that's equal to 0.56. Okay, so let's simplify this and see what we get. So 0.4 times 1, I'm just going to expand the brackets here. 0.4 times 1 would be 0.4. 0.4 times minus x would be minus 0.4x, just multiplying the minus x by 0.4, so minus 0.4x. And then we've got plus, and we've got 0.6 times x, that's going to be 0.6x, just putting them together. And that's equal to 0.56. Okay, so we've now got this. Now let's solve this equation and we'll find out what x is. So we've got, if we have a look at our terms involving x here, we've got minus 0.4x plus 0.6x. Well, minus 0.4x plus 0.6x would be 0.2x. So we've got 0.4 plus 0.2x would be equal to 0.56. Now we want to solve this equation, so let's take away 0.4 from both sides. So let's take away 0.4 from the left-hand side and 0.4 from the right-hand side. So on the left-hand side, we'll be left with 0.2x. On the right-hand side, we'll be left with 0.16. And then finally, we need to divide by 0.2 here. It's a calculator question, so that's quite nice. So we can just divide by 0.2 and divide by 0.2. And that tells us that x is equal to 0.8. So x is 0.8. And what was x again? Let's go to the question. X was the probability of Ben passing. So that was, I'm just going to change color of ink here because we've worked this out. So that's equal to 0.8. And that means the probability that Ben fails would be 1 minus x, that would be 0.2. Now the question asks us to find the probability that they both fail. So it's going to be Tom failing and Ben failing. So the probability that both fail, would be equal to Tom failing, 0.6, multiplied by Ben failing, which is 0.2. And 0.6, the probability that Tom fails, times 0.2, the probability that Ben fails, would be 0.12. So the answer is 0.12, and that's it. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on independent events. If you need any extra help on independent events, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 249, there's a dedicated video tutorial there on independent events. But in this video, we focus on the video solutions to the practice questions. I really hope you found this video useful. If you have found it useful, please like it. And also please subscribe to the YouTube channel. And at the end of this video, I'm going to put the icon up at the end of the video so you can just click it and hopefully that'll help you subscribe to the YouTube channel. Thank you. Cheers. Bye.